Simple harmonic motion. This video presents examples of simple harmonic motion. What is simple harmonic motion? An object that moves on a coordinate axis is in simple harmonic motion if its distance from the origin at time t is given by either d equals to a times sine wt or d is equal to a times cosine wt. Where w is bigger than 0, the motion has amplitude of absolute value phi, the maximum displacement of the object from its rest position. The period of motion is 2 pi over w, whereas frequency is w over 2 pi. Example 1. The displacement from equilibrium is given by the equation y equals to 1.5 sine 4t, where y is the displacement in inches and t is the time in seconds. Find the displacement t equals to 1 over 6 seconds. So let's start with the equation y equals to 1.5 sine 4t. We substitute t equal to 1 over 6, the equation becomes 1.5 times sine 4 times 1 6. Simplify, it becomes 1.5 times sine over 2/3. Now use the calculator, make sure it's in radian mode. So you should get 0.93 inches. Example 2. For the simple harmonic motion described below by the trigonometric function d equals to 9 cosine 6 pi over 5t, find the maximum displacement. Well, here is 9 and maximum displacement is equal to absolute value of a. So you substitute a, so you give the absolute of 9, which is 9. So the maximum displacement is 9. Example 3. For the simple harmonic motion described below by the trigonometric function d equals to 9 cosine 6 pi over 5 times t, find the frequency. Well, here w is 6 pi over 5 and the frequency formula is w over 2 pi. So you substitute w is equal to 6 pi over 5. So this becomes 6 pi over 5 divided by 2 pi. And now we multiply 6 pi over 5 by the reciprocal of 2 pi, which is 1 over 2 pi. Now you can simplify pi cancel with pi, and you're left with 6 times 1 is 6, and 5 times 2 is 10, 6 tenths, which simplifies to 3 over 5. So that's the frequency. Example 4. For the simple harmonic motion described by the trigonometric function d equals to 9 cosine 6 pi over w, 6 pi over 5 times t. Find the least positive value of t for which d equals 0. So what do you do? Set d equals 0. So, and then equation becomes 0 equal to 9 cosine 6 pi over 5 times t. Rewrite the equation. So 9 cosine 6 pi over 5 t equal to 0. Now using the definition inverse function, 6 pi over 5 times t would be r cosine of 0. And from the table of values or unit circle or calculator, I think r cosine of 0 is pi over 2. And I'll solve the equation 6 pi over 5 times t equal to pi over 2. So divide both sides by 6 pi over 5. So they cancel out to t, and you have a pi over 2 divided by 6 pi over 5. So you pi over 2 multiply with reciprocal of 6 pi over 5, which is 5 over 6 pi. Now I simplify, looks like pi cancel with pi, and you 2 times 6 will be 12, so it will be 5 over 12. So that's the time least positive value of t for which d equal to 0. Example 5. Find the model for a simple harmonic motion satisfying these conditions. The displacement is 0 when t equals 0, and amplitude is 4 centimeters, and period is what? 2 seconds. Because the displacement is 0, so we should use simple harmonic equation d equals to a sine wt. So a is the amplitude and the period was 2. We need to find w. So, well, use the formula for the period. The period formula is 2 pi over w. So we can equate this 2 pi over w with this period too. So now we solve for w. So in order to solve for w, I think we can here multiply w both sides, or just cross multiply w times 2. So you will have an equation 2 pi over 2w. And now this divide by 2, so you get 2 pi over 2 is equal to w over 2. Simplify, w equals to pi. We already know a is 4 and we found w equal to pi, and we put these values in the given equation. D equals to a sine wt. So the equation becomes d equal to 4 times sine pi t. Okay, we're going to find the model for simple harmonic motion satisfying the following condition. So displacement is 3 inches when t equal to 0. Amplitude is 3 and period is 1.5 seconds. Because the displacement is non-zero, so therefore we use this model. D equals to a cosine wt. Now we need to know a and w. A is given, amplitude is 3, and w we have to find. We are given the period 1.5. We can use the formula for the period. Period is 2 pi over w. So we can equate this formula with this period 1.5, and now we can solve for w. Well, we can cross multiply. We get 1.5 times w equals to 2 pi. And now we can divide by 1.5. So you have a w equals to 2 pi 1.5. And then you simplify. So, well, 1.5 is 3 halves. So you can say 2 multiplied by 2/3 reciprocal times pi, and we have 4 pi over 3. So now we already know a is 3 and w we just found 4 pi over 3. So substitute these values in the given equation. D equals to a cosine wt, and become d equal to 3 cosine 4 pi over 3. So what we learned in these two examples 7 and 8, whenever you have to find the simple harmonic motion model or equation, so either you use d equals to a cosine wt when the displacement is non-zero, when t is 0, and use the other equation d equals to a sine wt when the displacement is 0, when t equals to 0.